welcome back. In the previous video, we discussed the role of machine learning in data science. In this video, we will look at the role of NLP in data science. So without wasting any more time, let us get started. What is NLP? Well, NLP stands for Natural Language Processing. It is a subfield or branch of artificial intelligence or AI that enables computers to understand human languages and then process them in a valuable manner. It concerns the interactions between human spoken languages, that is, natural languages like English, and computers. Natural Language Processing, or NLP for short, it is broadly defined as the automatic manipulation of natural languages, like speech and text, by software that helps computers to observe, analyze, understand, and then derive valuable meaning from natural or human spoken languages. Tasks like translation, automatic summarization, and relationship extraction, speech recognition, named entity recognition, topic segmentation, and sentiment analysis can be performed by developers using natural language processing. NLP applications are hard or challenging as computers require humans to interact with them using programming languages like Java, Python, etc., which are structured and unambiguous. But human spoken languages, well, they are ambiguous and change with regional or social change. Hence, it becomes difficult to train computers to understand natural languages. We will not delve deeper into NLP right now. We will just look at the basic step, applications, and importance of NLP. Let us look at the components of natural language processing. So there are two components of NLP: Natural Language Understanding, that is NLU, and Natural Language Generation, or the NLG. Natural language has an extremely rich form and structure. It is very ambiguous. There can be different levels of ambiguity, like lexical ambiguity, syntax level ambiguity, referential ambiguity, etc. Now, lexical ambiguity is a very primitive level, such as word level. For example, treating the word boat as a noun or a verb. Syntax level ambiguity is a sentence can be parsed in different ways. For example, he lifted the beetle with the red cap. So did he use the cap to lift the beetle, or he lifted a beetle that had a red cap? Referential ambiguity means referring to something using pronouns. For example, Rima went to Gauri. She said, "I am tired." So exactly who is tired? Now, the applications of natural language understanding include sentiment analysis, profanity filtering, spam filtering, speech recognition, chatbots, and text summarization. So let us move ahead to the natural language generation. Now we have to produce meaningful phrases and sentences. That is in the form of natural language from the internal representation. This process involves text planning, sentence planning, and text realization. Text planning includes retrieving the relevant content from the knowledge base. Sentence planning includes choosing required words, forming meaningful phrases, setting the tone of the sentence. Text realization is mapping sentence plans into sentence structure. The applications of natural language generation include chatbots, text summarization, voice assistants, image captioning. Now we will look at the steps in NLP. So there are generally 5 steps in NLP. The first step in NLP is lexical analysis. It involves identifying and analyzing the structure of words. Lexicon of a language means the collection of words and phrases in a language. Lexical analysis is dividing the whole chunk of text into paragraphs, sentences, and words. The second step in NLP is syntactic analysis, that is, parsing. It involves analysis of words in the sentence for grammar and arranging words in a manner that shows the relationship among the words. A sentence such as, "The school goes to the boy," is rejected by an English syntactic analyzer. The third step in NLP is semantic analysis. It draws the exact meaning or the dictionary meaning from the text. The text is checked for meaningfulness. It is done by mapping syntactic structures and objects in the task domain. The semantic analyzer disregards sentences such as hot ice cream. The fourth step in NLP is discourse integration. The meaning of any sentence depends upon the meaning of the sentence just before it. In addition, it also brings about the meaning of an immediately succeeding sentence. The last step in NLP is pragmatic analysis. During this, what was said is reinterpreted on what it meant. It involves deriving those aspects of language which require real-world knowledge. It is time to look at the importance of NLP. So, why NLP is important in data science? Well, with the increasing amount of text data being generated every day, NLP will only become more and more important to make sense of the data and use it in many other applications. Chances are you have already been using some of the most powerful NLP applications but are not yet aware of it. Just take a look at Google Translate. Well, it is a free multilingual machine translation service developed by Google, powered by NLP behind the scene. Or maybe you have tried Amazon Alexa or Google Assistant to understand and answer your questions accurately via speech recognition. And that is again through NLP. NLP has basically changed the way we interact with computers, and it will continue to do so in the future. These AI technologies will be the underlying force for transformation from data-driven to intelligence-driven endeavors, as they shape and improve communication technology in the years to come. Well, I hope that you are now completely clear with the concept of NLP. In the next video, we will look at the role of deep learning in data science. Till then, stay tuned and keep learning. Bye.